Hello, everyone, and welcome to this masterclass explainer on human-machine interfaces, or HMI. I am absolutely thrilled to guide you through this today. Look around you. Whether you realize it or not, interface design dictates almost every single aspect of your modern life. In this explainer, we're going to unpack the exact science, the hardware, and most importantly, the human psychology that makes an interface either a total joy to use or, frankly, a complete nightmare. If you want to truly master this topic, you are definitely in the right place. We're going to treat this like a comprehensive deep dive, giving you all the structured, nuanced details you'd need to ace a high-level, 100-mark subjective examination on the subject. Okay, let's take a quick look at our syllabus. We're going to cover Intro to HMI Basics, hardware, software, and environments, the psychopathology of everyday things, human-centered design principles, screen layout and navigation, and finally, designing for the mind. All right, let's jump right in. Section 1. Introduction to HMI Basics, the fundamental medium between human and machine. So at its absolute core, an HMI is the vital communication bridge between human users and complex machines. It's the design and use of computer technology focusing precisely on that interaction. Think of it kind of like a translator. Without it, a machine's capabilities are just completely locked away from us. And this is critical across incredibly diverse fields. We're talking about the control panels of heavy industrial automation and SCADA systems, healthcare, where it dictates patient monitoring and MRI scanners, all the way up to transportation with aircraft cockpit displays. The interface is what makes the machine accessible to us. Now, if you want to critically evaluate an interface, you absolutely must judge it against these 6 primary goals. Consider this essential, high-yield knowledge for any exam. First, effectiveness. Can the user actually complete their intended task accurately? Second, efficiency. Can they do it quickly and with minimal physical or mental effort? Third, safety. The system absolutely must prevent dangerous or irreversible actions. Fourth, learnability. How easily can a complete novice just pick it up? Fifth, memorability. If you don't use the system for, say, a month, do you have to relearn the whole thing? And finally, user satisfaction. Is the interaction actually comfortable and pleasant? A truly successful HMI hits every single one of these targets. Section 2. Hardware, Software, and Environments. The 3 pillars of operational context. It all starts with the physical constraints. Hardware dictates your physical interaction limits. It decides the display size, the processing power, and your input methods, like touchscreens versus keyboards. Software, on the other hand, well, that's the invisible engine. It processes those user inputs, manages the visual interface elements you actually see on the screen, and controls the overall behavior of the system. But here's the catch. Even the absolute best hardware and software combination will fail if you ignore the 3rd pillar. Because an interface does not exist in a vacuum. It exists in an operating environment, and a brilliant HMI design heavily considers 3 sub-environments here. First, the physical environment. Is the user standing in a dark, noisy factory wearing thick gloves, or are they sitting in a quiet, brightly lit office? Huge difference, right? Then, the user environment. What is the user's skill level, their cultural background, or cognitive ability? And finally, the organizational environment. What are the specific safety rules and standard work procedures? You simply cannot design a medical device for a high-stress emergency room the exact same way you design a consumer smartphone app. Context is everything. Section 3. Psychopathology of Everyday Things. Why bad design causes human suffering. We literally call this the psychopathology of everyday things. Let's break down those Greek roots for a second. Psycho means mind. Pathos means suffering or disease. And logy is the study of. So this is the literal study of how the poor design of everyday objects causes us mental distress. The fundamental idea here is profound, and you should definitely remember this. If users repeatedly make mistakes, the problem is almost always the design, not the user. People aren't inherently careless or unintelligent. They're just victims of confusing interfaces that totally fail to map to human intuition. And honestly, this image brilliantly illustrates our point. Imagine walking up to these beautiful, identical doors. They've got these flat handles. Now, to the human brain, a flat plate visually indicates push. But what if this door actually requires you to pull? You're inevitably going to push, slam into the door, and feel foolish. But you really shouldn't feel foolish. This is a classic failure of visibility and affordance. The design essentially lied to your brain. Or, take a look at this absolute masterpiece. This teapot is perfectly designed to pour scalding hot water directly onto the user's hand. It completely violates the fundamental HMI goal of safety. It's a really funny but fantastic example of a designer prioritizing aesthetic novelty completely over human-centered function. Even a visually interesting coffee cup can be a total disaster. Just imagine actually trying to drink from this without spilling coffee all over your shirt. It fails entirely because its design completely ignores the physical reality of how a human mouth and liquid actually work. It lacks basic usability. Section 4. Human-centered design principles. Adapting the machine to the human. To fix these everyday frustrations, designers rely on conceptual models, which is essentially how a good design communicates its function directly from the designer to the user. Don Norman, a legendary pioneer in this field, outlined 4 critical concepts you need to memorize. First, feedback. The system must give a prompt, predictable response so you know your action actually registered. Think of an elevator button lighting up the second you press it. Second, constraints. Physically or digitally preventing the user from making incorrect choices in the first place. Third, affordances, the physical qualities of an object that intuitively suggest how it should be used. And fourth, the power of observation, relying on the clear, obvious visibility of actionable items. Now, it is absolutely vital to understand the difference between affordance and mapping. Affordance is about the object itself. A flat plate affords pushing. A handle affords pulling. Mapping, however, is the relationship between the controls and their effects in the real world. A classic example of poor mapping is a stovetop, where 4 burners are arranged in a square, but the 4 control knobs are placed in a straight line. You constantly have to guess which knob turns on which burner, right? Good mapping aligns the control directly with the layout of the consequence, creating a perfect mental model for the user. Section 5. Screen layout and navigation. Organizing digital spaces efficiently. Let's move into the digital space. Notice how structuring data actually reduces cognitive overload. By grouping associated elements logically with proper borders and leaving adequate white space, we heavily reduce visual clutter. A strong interface flows sequentially, usually top to bottom and left to right. Now, pay attention to this crucial contrast. We place the most frequently used primary window functions, like your main navigation and everyday inputs, where the eye naturally goes first. Conversely, secondary window functions, which might involve complex settings or tasks with a high cost of error, are deliberately separated. They usually require distinct, deliberate actions, like accessing a dedicated dialog box. The goal is always to minimize the distance the pointer and the user's eye have to travel for primary tasks. So the crucial point here is efficiency, and one of the absolute best ways to achieve that is by minimizing the number of times a user's hand has to physically travel between the keyboard and the mouse. This is a vital cheat sheet of common keyboard control navigation shortcuts that power users rely on. You use the tab key to move between operable controls in a logical sequence, but within a specific group, like a cluster of radio buttons or grouped checkboxes, you use the arrow keys to navigate. And for the fastest direct access, interfaces should use mnemonics. These are specific keyboard equivalents like hitting Ctrl-S to save to jump straight to a command. Mastering this fundamentally speeds up task completion. Section 6. Designing for the mind. Cognitive load and the future of interfaces. Human psychology dictates incredibly strict rules for interface designers. First, the law of proximity. The physical distance between objects on a screen visually tells the user if their functionalities are actually related. Next, reading is easily destroyed by bad design. Using complex jargon, tiny fonts, or placing text over busy backgrounds immediately spikes the user's cognitive load. Furthermore, humans learn so much faster when the risk of exploration is low. This means bad actions must be easily reversible with robust undo options, and constraints should automatically deactivate invalid choices. Finally, time really matters. System responsiveness needs to perfectly match the flow of human thought. If a user has to wait more than 1 to 2 seconds for a response, their concentration breaks, and their short-term memory actually begins to degrade. As we look to the future, we are rapidly moving beyond just flat screens toward natural user interfaces, or NUIs. A striking example of this future is projecting a keypad directly onto the palm of a hand. The interface leverages the user's innate sense of their own physical body. It uses natural human behaviors, gestures, and 3-dimensional space. The technology is finally, literally, molding itself to the physical human form, completely dissolving the traditional clunky barriers of interaction. Well, we have covered an incredible amount of ground today, from the rigid fundamentals of HMI goals to the deeply nuanced psychology of why a badly designed teapot can actually make us angry. Your mental model of the world around you should now be forever changed. So I'm going to leave you with this challenge. Look around your room right now. What is one object you can spot right this second that suffers from a poor conceptual model, terrible affordance, or bad mapping? Once you start looking for the psychopathology of everyday things, I promise you, you will never be able to unsee it. Thank you so much for joining me in this explainer and keep analyzing the world around you.